Hello, welcome to the presentation of the final project of subject Advanced Computing Concepts based on web search engine, and our project is titled as KeyFinder, and my teammate is Janani Suresh Kumar and myself Eswaran Badrinarayanan Venkateswaran. So let's get started with the project. So, first, let us look at the outline of the project. First, we have abstract, where we just go through what all summary it has and what are all the concepts that outline in that, and then we'll run through the concepts that the project covers. Basically, it has a lot of components that is associated with the project, so we'll go through one by one. We will list them as well, and then the third thing we discuss here is about the search engine architecture, about how various components in the what we say in the concepts, like how their interactions facilitate the search of various words in the URL, and then from there we discuss more about web crawler, which really is the main component of the web search engine. And then we move on to HTML to text parser, which basically converts the HTML files into text files with the help of tree algorithm. And then we move further to page rank, which basically identifies every files the word is present. I mean, every URL the word is present, and it sorts according to the word frequency count. If in case the user enters a misspelled word, which we'll look a little more deep when we go into the slides, there'll be a continuous steps of redirection, and then which is followed by a conclusion at the last. So first, what's our abstract or what's our main aim of the project? First, we create a search engine that crawls thousands of BBC websites via web crawler and then follows these pages to find new ones. Actually, it can be any site. For instance, it may be w3.org, it may be tutorials.com, so it may be any irrespective of the site that we follow, but the principle is same everywhere and it's applied for each and every concept. So the crawler first traverses through the DOM, that is the document object model, and the data obtained by the browser with the first search and crawls through all the linked sites on the internet. So by this I mean the web crawl just searches for entire URL of the World Wide Web Consortium through an object called through a concept of Java DOM, which is the document object model. And then what happens is that the crawler downloads the human readable contents to a file that can be later used by a search engine. Features and functions such as reverse indexing and autocomplete are added to enhance user friendliness and to display the users with a set of relevant and curated search results to improve performance of the search engine as well. Coming on to the concepts, we have listed it here. Is the first thing is the web crawler, or it is also known as spider, and then we have Jsoup Parser, and then we have tree, which is the tree algorithm basically, and then we have string tokenizer, followed by autocomplete, which is the edit distance, and page rank. So let us have a quick brief overview of what all these concepts and or what do these concepts contain. So first talking about the web crawler. So it basically crawls the web from the whole www.com. So it's the World Wide Web Consortium. It just crawls every single files that it has, and then into URL. For example, as I already mentioned, as w3.org, it uses BFS, the concept of BFS, that is the breadth first search. It first traverses through every other file that is located on the internet, and then comes back from once if it is traveled deep down in depth, and then comes layer by layer on top. So the second concept here is the Jsoup Parser. So basically, the web crawler employs this parser for the conversion of HTML to text, so which is effectively done by Jsoup Parser. And then for the try algorithm, try is basically used for text processing, the data that is converted from HTML to text. So this algorithm does the functionality of conversion. And the next thing is string tokenizer. In an HTML5, it may contain a lot of words. Say, for example, it may start from over 100 to about 10,000 words. So whenever a user searches for a particular word, he needs to be specific about that, right? So in order to eliminate all of the other words, it really tokenizes each and every word in the file and removes the unnecessary or irrelevant words to the context according to the user search word. So it tokenizes every word in the HTML file, and I mean the text file, the HTML text converted file. Next up, we have autocomplete, which uses the edit distance. So what do you mean by that? Like, we offer suggestions, like the user enters a particular word. If it is misspelled or the system recognizes that there could be another potential match for that word that closely matches with the user entered word, so there comes a suggestion which implies the algorithm of edit distance, which basically compares the closeness of the word entered by the user and the word that is present in the file. And next up, we have followed by page rank. Page rank really determines the word frequency count, and it really implies the and it follows an order of descending, which which is based on the frequency count. As I said, for example, a word may have a frequency count of 5. Another word, the same word in the different file, may have a frequency of 1. So, which means that 5 will go first, followed by 1 in the display. So this is a brief overview of the concepts that we have in our project. So moving on to the architecture. So we'll just discuss the flow from where it goes. We'll just try to trace what happens exactly in the search engine. As I already said, web crawler goes straight into implies the concept of Jsoup. So Jsoup basically has two functionalities to do. Jsoup is used to conversion of HTML to text, and then it crawls all the HTML files located in the web in the internet, and then from the HTML text it tokenizes, as I already said, it tokenizes every word. So which is really important in order for the parser to locate the exact user search word. And then it goes on and tries hash table, so which really stores the tokenized words in the form of a hash table so that it can be easily fetched. And then it compares the word frequency, and the sorting algorithm is performed it. So as I gave an example already, which cites the frequency count for each searched word in all of the files, and then it is displayed in the form of a descending order sort as a result to the end user. And just consider a scenario where a user enters the word on the left. We have a user who enters a word there and he searches for it. So if the result turns out to be yes, it goes straight into the hash table, which has all of the crawled and converted files and words that are already tokenized. It goes there and makes a comparison of the searched word to the hash table. If the word is present, it compares the word frequency, and the sorting is done again, and it's displayed. And this is repeated. If not, the autocorrect comes into display. This is where the edit distance algorithm is employed. And again, here it goes back into the try hash table, and then it again displays the end result. So this is the basic overall architecture or the system flow of our web search engine. So coming on to web crawler. What do you mean by web crawler? A web crawler is also known as a spire, is a form of bot that is commonly used by search engines such as Google and Bing. Their goal is to index the content of websites from all across the internet so that they can appear in search engine results. For example, Google has its main crawler, Googlebot, which encompasses mobile and desktop crawling. But there are also several additional bots for Google, like Googlebot Images, Googlebot Videos, Googlebot News, and AdsBot. So these bots are mostly operated by search engines. By applying a search algorithm to the data collected by web crawlers, search engines can provide relevant links in response to user search queries, generating a list of web pages that show up after a user types a search into the search engine. A web crawler, as I already said, is a bot, like someone who goes through all the books in a disorganized library and puts them together in a card catalog so that anyone who visits the library can quickly and easily find the information that they need. To help categorize and sort the library's book by topic, the user will read the title, summary, and some of the internal text of each book to figure out what it's about, right? So that's how it's employed the same in the form of links. So here it is a concept of search indexing as well. Like search indexing here is like creating a library card for catalog for the internet, so that the search engine knows where on the internet to retrieve when a person searches for a particular word. So it can also be used to compare to the index, which lists all the place a book or a specific place where a book or a phrase is contained in the book. So, and indexing focuses mostly on the text that appears on the page and on the metadata as well about the page that generally users don't see, and which users are restricted access to see that. And they also the search engine goes through all the indexes and all the pages whose words appear to be a close match and selects the most relevant ones to the users. And we have also have employed the concepts of stop words, which will be further discussed in the moving forward with the presentation. So let's move on. Now, here we got Jsoup Parser, which is employed by web crawler. So what is it about? Jsoup is a Java library for working with real-time, real-world HTML environment. It provides a variety of convenient API for fetching URLs and extracting and manipulating data using the best of HTML5 DOM methods and CSS selectors. So basically, it is employed by web crawler to perform sets of functionalities. It does scrape and parse HTML from a URL. It not only includes these functionalities, it also has the functionality of to find and extract data, to manipulate the HTML elements, attributes, and text, such as the styling, the font. Everything can be done and can be modified accordingly. It can also be used to submit content against a safe list to prevent XSS attacks and to just tidy the output HTML. So this is a brief overview about the HTML parser. Now, my teammate Janani will take over for the rest of the presentation, followed by this try algorithm. Thank you.
Thank you, Ishwar. So let me go ahead and start explaining about try algorithm. So try algorithm is a tree-based data structure which is used for information retrieval. So we have implemented a try algorithm in our web search engine using hash tables. So it is the fastest algorithm which is used for pattern matching. We have implemented the page rank to count the frequency of the word that the user has entered. So for that, we have to first extract the data from the web page using Jsoup, and then we have to split the strings into the tokens and remove the useless words such as rejects and stop words. Then we have to search the web pages for the search word that the user has given. Then we have to count the number of occurrences or the frequency of the word and assign the rank for the page. We have used spell corrector in our web search engine. So what it basically does is that if a user enters a word which is incomplete or which is wrongly spelled, then it can be corrected by using the edit distance algorithm. So it is a comparison of two similar strings. So it will compare the distance between the two strings by taking the word from the dictionary, and it will find the shortest edit distance and it will return it to the user. So let me now explain about the code as well as the demonstration. So in webcrawler main.java, we are using a reference URL that is w3.org. It contains all the web pages and it basically acts as a web page repository. So here we are setting the maximum depth to be 10 and the maximum pages to be fetched from the w3.org to be 50. So here it converts the HTML pages to text. So for that we are using the Jsoup parser. So what the Jsoup basically does is that it converts all the HTML pages to text files and store it in the path which is mentioned here. In search engine.java, we are first creating a try. So for that, we have to perform string tokenizer by splitting up the strings into tokens. So for that, we have to first remove the useless words. So here, the useless words are word rejects. It contains all the special characters that is not necessary to be associated with the word. And along with that, we are using the stopwords.txt. So this text file contains all the unnecessary words linked with the search word. So by removing all these words, the efficiency will be improved. And once the user enters a search word, it will search all the links, all the text files for the particular token, and it will be displayed. If the search word is not found, then it will print that the word is not found in the file, and it will also provide suggestions. So for the suggestions, we are here using the edit distance algorithm. In editDistance.java, we are comparing the two strings. So if the word entered by the user is incomplete or wrongly spelled, it can be corrected by using the editDistance method. So here we can see the length of the two strings is taken and the distance is calculated using the editDistance algorithm, and the one with the minimum distance is being displayed to the user. In try.java, we are creating tries. So tries basically contains nodes, roots, and children. So it is a tree-based structure. So the implementation of tries is done using hash map. So when the user enters the search word, it is searched among all these tries, and if the word is present in the tries, then the page index of the word is returned, or else it will display null. In PageRank.java, we are calculating the word frequency for the searched word. So for that, we are first creating a hash map to store the rank of the page of the search word. So then we are using the Jsoup to connect to the web page and extract all the page content. So here we have to first remove the useless words like the word regex and the stop word. So for that, so first we will remove it, and then we have to sort all the words. So for that we are using the tree set. So after sorting all the words, then the word count is being increased if the search word is present. We are increasing the word count here, and if there are no more words in the page, then the word dot count will be returned to the main. Console.java is the main file for our web search engine. So here you can see a lot of function calls which I previously explained. So firstly we will be creating the tries, and after the tries have been created using the URL page, the user has to enter the word they want to search. So after removing all the useless words, the page rank. Yeah, for sorting the page rank, we have used the linked hash map. So linked hash map, we have sorted it in the reverse order, which means the word having the higher frequency will be displayed at the top, and the word having the lowest frequency will be displayed in the bottom, like in the descending order. So that's it for the coding explanation. So now let's begin the demonstration of our web search engine. So first I've created the tries using the hash table, and now it's been created. I can search whatever word I want. So now I will type Canada here, and it will now search the all the text files for the word, and yeah, here's the results. So since I gave the depth as 5 in the web crawler, 5 links are getting displayed here, and you can see the page rank is in descending order, and for sorting it we used linked hash map. So for your reference, I can copy paste it to just check whether the page rank is working. Canada, and you can see there are 5 Canadas here. So the page rank here is also 5. So yes, the page rank is working. So do you want to continue? Yes, I want to continue. So here, let me mispronounce the name and type apparently. So it has to say apparently, then the autocorrection works. Yeah, apparently is written here, and the edit distance algorithm works properly. And I just type welcome. It has to show welcome. Yes. So let me. Okay, duck. Okay. So no, I will just end the demonstration. So this is what we did in the coding and demonstration part, and we'll finish it off with the conclusion. In conclusion, we learned how to put various concepts into practice in order to construct real world applications like Google search. We also learned how to recognize which algorithm, concept, or feature is best for creating an efficient application. We assess the algorithm's time complexity as well as the space complexity and choose which one and chose the one with the lower complexity to reduce the search time for user queries. Thank you.